Well, welcome to Emerald Hill Skies. My name is Doug, and we're here on the outskirts of Louisville, Kentucky. And tonight, it's an incredibly moonlit night. In fact, I have a little picture of the moon here. I'm going to check the audio. Ken, good to see you aboard. All right, we've got some audio there. Stu, glad to have you. Welcome. Anyway, this is not sunrise. This is moonrise. We're at 99% tonight. So a lot of people would think it'd be crazy to do astronomy on a night when the moon is like a searchlight beacon. But here at Emerald Hill Skies, we believe that, you should not let that chase you away, because you should be able to figure out a way to work around it somehow. So that's what we're going to try to do tonight. We are running a RASA 11-inch on top of an iOptron CEM 70G mount, and we have that on top of a adjustable height pier from Pier-Tech. We use a little equipment plate on top of the RASA with a 178 camera, and that gives us these sky views. And tonight's sky view is particularly troubled with, look over there to the right, and maybe you can see a tremendous amount of blinding light. It looks like, Saul was on the road to Damascus in the biblical proportion or something. That's the moon. Anyway, we use that 178 camera that's up on top, that little red camera you see there, and that gives us our views of the sky. We have also a couple of Pegasus Astro pieces there, a power box and a USB hub that pulls everything together and sends it down to this rig rack deal that takes care of power distribution and also converting all of those images to fiber-optic-relay from this ASI2600MC Pro color camera by ZWO. And from the observatory out there about 200 feet away, it pulls all those images in so that we can see them here tonight live from my office, which is inside a nice bug-free building, moisture-free building. And we observe as if it were right there beside the scope together, you and I. We're happy to have you. I see we've got not only Ken and Stu, but Tiffany, you're back. Welcome. And John, good to have you here from up in Canada. I think you are. Very full moon. Thank you, Tiffany, for your encouragement. Great to have you guys here. It wouldn't be the same without you. All right, let's see what we got. Let's see, there's the telescope out in the observatory. You can see it looks a little bit like broad daylight there on the left. And now let's pull into the, see, we're going to link our scope to our observing software. And now we're going to try to come here to look at the view that's live through our 126, the MC Pro camera. And I think we better pick our objects with care tonight, don't you think? Like, how in the world will we see some of these things? But let's just give a few a try. In terms of sheer altitude, if we look at sheer altitude, here is a planetary nebula, a dark nebula. Here's a single star. Why are we looking at 5164? I see 5164. No pun intended, but let's go see it. So we'll just slew to that. And while we're slewing to that, I see 5164. Let's turn to it. It's Cosmic Challenge number 62. Why are we looking at a single star? I see 5164. Oh, it's not exactly a single star. It's an emission nebula. That's mislabeled, isn't it? How can we edit that? Well, let's give it a try anyway, since we're here. So we'll, I'm eager to see if we can. Well, it seems to have worked tonight, so that's exciting. Let's go back to our live view, and we'll connect our mount. It's already connected, and we'll do let's just go in the sequencer and say next target, and we're going to put in the name here, IC5164. The mount's already settled, and now that'll do a plate solve on that region of the sky. Make sure we're indeed looking at the right region. The Cocoon Nebula, Stu says. IC5146. Is that right? Is IC5146 is really the Cocoon Nebula? Or were you looking at IC5146, Stu? Because we're supposed to be at IC5164. Try that out. IC50. Oh my goodness, look at IC5146 is correct. How can this be? Object 62 I see. So there is a problem with our object here. Edit plan. Edit plan. IC5146. How do we correct this? Because I think you're right. Object number 62 is supposed to be 5146, but I went to IC51. No, I should have gone to the, I'm sorry. I did go to these coordinates, but I have it mislabeled in our list here. Let's see if I don't even know how to change the, it's not letting us change that object. Let's see how bad off we are here. Oh, here we go. Now we can change it. So this should have been IC5146. IC5146. Should be object number It is the Cocoon Nebula, isn't it? Is it the same as Barnard 168? Yes. Well, I'm pretty sure this is not the correct place for that. So let's go to the next target here. IC5146. And let's slew to this. Yeah, it's in a different place. Well, that's the problem. When you have to make your own observing list, sometimes you have typos. We weren't actually too far away from the right place in the sky, were we? Boy, you can see that moonlight, so I don't know whether our RASA is going to be able to pull this in tonight with that moonlight. I was thinking if it was a single star, we could do it, but if it's a dark nebula, how are we ever going to see that, right, guys? Anyway, the Cocoon Nebula is located in a crowded field of stars spanning approximately 2 degrees. The NGC description refers to IC5146, also known as Colander 470, as a cluster of 9.5 magnitude stars involved in a bright and dark nebula. IC5146 is a compact star-forming region with a long trail of obscuring interstellar dust clouds. Oh, it's not your fault, Stu. It was my fault. IC5146, also Caldwell 19, SH2-125, Barnard 168 in the Cocoon Nebula is a reflection emission nebula, and Caldwell object in the constellation Cygnus. Kevin Girl, good to have you here from LA, Kevin. Well, we're going to see if we can make anything out of this. There is something already funny about the middle of that. You don't think you can already see that, do you? Surely not. We're just using barely beginning of 3-second exposure. Surely not. Barnard 168. Let's see if we can show this on the chart. My goodness, it is going to show up. I would never have believed that. I was scared of going to the nebulae tonight. I was thinking we wouldn't be able to see any, but look, we can already see it after just 20 seconds. How is this possible? Okay, we're going to do a display histogram restretch there, and then restretch and auto stretch our main histogram. We're going to do a color map. Actually, that color is great already. Look at that. How did that know? And then we're going to pump up these mids because you can already see it. That's remarkable. Now it is grainy, but some of that grain will settle out. We're kind of over pumping our mids with the amount of integration we have. We just have 80 seconds so far. So what this is a hydrogen alpha cloud that is obscured in the middle by a dark nebula, like a bunch of dust and stuff. And Phil Harrington writes, as a group, emission nebulae or hydrogen-2 regions are the most difficult deep sky objects to see visually. The problem is that they emanate light in very narrow segments of the visible spectrum, with their brightest emissions in the red wavelengths. That's a problem, since the human eye is all but colorblind to red light under dim light conditions. Arguably, the only objects more difficult to spot than emission nebulae are the opaque profiles of dark nebulae. These cosmic dust clouds are themselves invisible. We only see their silhouettes against a starry backdrop. No starry backdrop, no dark nebula. It's that simple. That brings us to the double challenge in Cygnus, IC5146, known to many by its nickname, the Cocoon Nebula. It's a taxing patch of glowing gas, while Barnard 168 is a thin, sinuous lane of darkness that seems to start at the bright nebula and extend far to its northwest. So he says to spot this, he begins to tell you how to find it, how to steer to it. He says it's going to be hard to see. He says you only get a little bit of help from so-called nebula filters. And then he talks about how hard this was to discover. There's a bit of a debate of who discovered it, but Edward Emerson Barnard photographed it in 1893 and kind of proved it. Some sources claim that IC5146 is a star cluster, not a nebula. In fact, a cluster of more than 100 young stars is embedded within the Cocoon Nebula. Espin's original notes, however, referred to his discovery as a faint glow about 8 arc minutes across, well seen each night. And he was looking through, a giant observatory commercial telescope. Swedish astronomer Per Colander saw it in 1931, called it Colander 470. He himself apparently caused some confusion when he incorrectly cross-labeled it as IC5146. The error has been carried over to many other references, including the first edition of the popular Uranometria Star Atlas. Modern studies show that 110 stars belong to Colander 470. Unfortunately, most of the other cluster of stars are too faint to be visible through amateur telescopes. So we can see quite a few stars there if that's the cluster, can't we? It's very pink in Hubble images. BBS, astronomer steroids time, coffee. Well, I think this is really cool that in just 20 seconds we can start seeing this. Let's go beyond our optical zoom and let's approach this with 180% of our digital zoom. And let's go ahead and pump up the mids a little more now and make those cluster stars pop a little more. Let's make the sky a little darker by turning up what we're going to consider to be the threshold of the definition of black in our large histogram. Let's also make our on-screen image. And let's get that title out of the way because that is wrong. That is supposed to be IC5146 or Barnard 168. Dark Meta, good to have you back. All right, so I don't know what looks like a cocoon here. Why did we call this the Cocoon Nebula? Maybe because this is an elongated hydrogen patch and this black thing in the middle is the worm inside of the cocoon, you think? Now these two bright stars are probably the two that are typically seen visually, but of course using electronically assisted astronomy with this RASA 11, we're able to see a lot more of the cluster. Now I think the cluster is probably the thing that's lighting up the hydrogen, don't you guys think? So the hydrogen is actually popping. It's being like ionized by all the light from this cluster. And then this cool dark lane of soot or dust or whatever kind of dark gases that is, those are kind of hiding the hydrogen from us, making that dark nebula. So we're actually seeing three things at once in this image. And this is live, don't forget. We're seeing a star cluster named IC5146. We're seeing a nebula that's named, what would the nebula be named, guys? I guess the nebula would be named, does the nebula have a separate name? We'll call it the Cocoon Nebula. And then the third thing we're seeing is the Dark Nebula. The Dark Nebula is Barnard 168. So let's do our observation here. And what we mean by that is we log these. If you've seen the channel before, you know that we create a log entry. And we're going to say 3 objects in one. The star cluster, which is IC5146. By the way, Stu, thank you for catching me that I had a typo. I was saying 5164, and you caught me on that. Thanks. The star cluster, the nebula, which is, we'll call it the Cocoon Nebula, and the hydrogen, the H2 hydrogen nebula, and then the Dark Nebula, and we'll call that Barnard 168. Showed up on this 99% moon-filled night after just 20 seconds. At 8 minutes, it's gorgeous. Now I think on a darker night, that sky would be darker. So let's simulate that. I'm going to pull our histogram over a little more. and get rid of the moonlight. So what we're doing is we're basically increasing the threshold of light and blocking out all the moonlight. We can do that with electronically-assisted astronomy. Now all that remains is the H2 region, and we lost a little bit of it when we darkened the sky, but we can still make out quite a bit of it. It's really fun, isn't it? Hey, Corin, glad you're here. It's kind of late for you to be up. Yeah, 2:50 a.m. Yikes. Stu's in New Zealand, 3 p.m. in New Zealand. And all right, we're going to grab a picture of this exactly as seen. And now, at this point, we could do several things. We could, it looks like to me that the sky is the limit. That's almost like a pun that I didn't intend. It looks like nothing is going to stand in our way, so maybe let's just keep going in order. I was thinking we'd have to do things tonight that, you know, would fit with a moon being 99%, but now I'm encouraged. Let's try this next thing, which is at 71 degrees is NGC 6886. It's object number 102. So we're going to salute to it. Object number 102. It's NGC 6886. If I didn't do a typo this time. When we talk about object numbers, we're referring to the list in Phil Harrington's book, Cosmic Challenge. And so now we're going to go to object 102 here. And you might say, well, how do you decide this order? Because we're obviously going out of order here. Well, the only way I know to do this is to hop around by altitude. And that's just because of the nature of the fact that these things are at different heights above the horizon. And in general, we want to go to the highest things first, I think. You can see the telescope now is pointing almost straight up toward the zenith. 71 degrees above the horizon, in fact. And boy, I love that new security cam. It's made by, what is it? TP something or other. Tapo is the name, the model name of it. TP Link, I think it's called, is the company. And boy, it's doing a lot better job than any security cam, any kind of scope cam we ever tried to use, isn't it? Look in your sky cam view and you can see all the brightness. It's a wonder we can see anything in that sky except for the brightest stars. It's just flooded. All these dim objects, I can't understand how we can see any of them. But sure enough, we'll try. Now, what about this NGC 6886, Stu? It's a planetary nebula in the constellation Sagitta. It was discovered by Ralph Copeland, September 17, 1884, and it expanded between 1280. Oh, it's been expanding for between 1280 and 1600 years. So what's happening right now is our camera and our software, we use a software called SharpCap. They're working together to try to look through the telescope and make sure that the view through the telescope exactly matches where the coordinates from our observing software, which is called Deep Sky Planner, told the mount to go. And you can see a little correction there at the very end when the stars kind of coasted a little bit off in another direction. And that was the mount having been given instructions by SharpCap to correct itself a little bit. And The next thing that happens is we switch from, this is all a little bit of a sequence, a little program. We switch from 3-second exposures to 20-second exposures. And we start live stacking those exposures. And what live stacking means is we basically take one time exposure on top of another, and through the magic of this software, SharpCap, we start loading them on top of each other. And that enables the camera to see things that otherwise would be very difficult to see. Another thing we can do is kind of zoom in, and I'm guessing that that is the planetary nebula, but there's another piece of magic we can do here, and that is once the software is aligned correctly after that movement, it does another test here with the night sky. And once it aligns exactly correctly in this new frame that we have, we can use something called deep sky image annotation, and it will try to mark, there we go. It'll try to mark what exactly is the planetary nebula. And the one we're looking at here has been circled for us now. And look how precisely the software will circle it. That is NGC 6886. It's not that much different than the stars around it, is it? Kind of reminds me of the planetary nebula that we looked at, was the last week or week before. And the only way we could tell that it was a planetary nebula was to zoom in. And when we zoomed in, we could see a little bit of the hollow portion. You kind of have to use your imagination just a little bit. You can tell it's a little bit of an oxygen, and that would be very uncommon for a star to actually have a green glow like that. So that's basically what leads us to understand it's not a normal star. And then if we use our imagination with the mids turned way down, sometimes we can see that central star bit, but not on this one very much. What do you make of this, Stu? It is 15,000 light years distant from Earth, composed of a hot central post-AGB star that has 55% of the sun's mass, yet 2,700 times its luminosity, with a surface temperature of hot, very hot, 142,000 Kelvin. At 3 minutes, I don't know if we're making out that central star, but we can definitely see the greenish tinge at lower brightnesses. To the casual eye glancing through a telescope, it looked just like another field star. And since it's poised along the eastern edge of the summer Milky Way in Sagitta the Arrow, let's go look at that. Sagitta the Arrow. Yeah. NGC. So is it this? Yeah. So even in our planetarium software, this is our planetarium software that's supposed to show us, you can't see a central star even in the planetarium software. Look at that field of stars and how this planetary nebula stops looking like any planetary nebula. It's so teeny. Wonder what the 6 arc seconds It says at 6 arc seconds we should be able to resolve it as a disk, but boy, it doesn't look much like a disk to us. But with the Hubble, it has 2 wings. Extending on either side of the circular inner shell. That's what makes it 6 arc seconds. Boy, he says it's super hard to find visually. And it is oxygen, indeed. That's why it was green. So you can see for a visual observer, this would be very, very difficult. But for EAA, which gives us colors, it's really not so bad. We can see that green. Now here's my question. Stu says that looks nothing like the Hubble picture. Corin says he has a TP-Link camera too, a great one. Can't see the central star in the Hubble picture either. Yes, I feel better. I feel redeemed. The only thing that we're seeing here is the green, but I'd like to dare us to try to find something. Can we tell that it's oblong? For instance, when we look at other stars, they should be pretty even. No, we're not able to see much oblongosity. We can't see much oblongosity, but I thought maybe those ears would show up. That's 7 minutes. Anybody seeing the ears? Okay, let's look at the pixels. Now this is how tight we're in on this camera. We're at 1,965% of this camera's optical ability, and we're clearly now relying solely on digital zoom. But look at the way the pixels are brighter in this direction and that direction. And notice how the pixels fade as you go out toward the corners of the quadrants. In other words, it's brighter at the 12, 3, 6, and 9, and then it's dimmer at the 130, 430, 730, and 1030. So now let's go look at the Hubble view. Wikipedia, NGC 6886. Oh my goodness. That is incredible, isn't it? So see, you can see why it's brighter in the north and south and the east and west. And then you can see why it's dimmer at the 130, the 430, the 730, and the 1030. Now, our RASA telescope, 11 inches, couldn't pick up these lobes like the Hubble. But when we pixel peeped at the very limits, 2000%, we were able to see that there was an oblongosity to this object. I think that's cool. It's really a beautiful image. Well done, Hubble. All right, so let's do this log entry here. And what we're going to say is tiny 6-second of extent planetary. Our RASA didn't pick up a central star, and we couldn't even see the lobes, but we could barely detect a, what would you call that, like a brightening effect at the 12 noon, 3 p.m., 6 p.m., and 9 p.m. corners of the nebula. Then we went to see the Hubble and could clearly see why. Again, I think it's something that, you know, electronically-assisted astronomy allows you to make guesses based on what we're observing in real fact. And then we can go look at something like the Hubble Space Telescope and understand the why. So I guess it's a tribute to why the Hubble is so cool. We're not going to grab an image of this because it won't say much. Hubble got to look at it for a lot longer too. Good point, Stu. That's a very good point. If you spend 3 weeks taking one picture, you'd get a good one too. That's a great point. All right, I guess we'll go at object 105 next. Why should we not? Why should we shy away from anything? This is IC5217. IC5217. And this is Cosmic Challenge 105. So you see our scope now is, the weights are east and the scope is pure west. Let's figure out where we are in the night sky. And let's show chart again. And we're supposed to be looking at IC5217, so I'm just going to Control S here. Control S. Why does it not pick up sometimes? It's like it doesn't remember my... Here we go. IC5217. Boy, it's so missing, whatever it is, that it isn't listed in Stellarium. It isn't even pictured in Stellarium. It's just a symbol. Six arc seconds again. Anyway, we're looking toward the, what? Northeast, maybe? Here's east, and there's north. So if you go up past Polaris and go up as high as Cygnus and Lacerta, I don't know that I've ever observed anything in Lacerta. Have you guys? This is not a constellation I've ever visited before. I remember the Elephant Trunk Nebula. Anyway, we're looking northeast. Let's see what we've got here. we'll do this display histogram reset. For some reason that always acts up. This is a new version of SharpCap. First time we've used it. Boy, right there is that planetary nebula. It's really looking good, isn't it? We'll reset this just in case it needs it. I bet that's it. We're gonna plate solve only again. Huge slew, Stu says. IC5017 is a planetary nebula in the Lacerta constellation, the magnitude of 11.3. And this is object number 105. Our fall inventory kicks off with a taxing planetary nebula in an equally taxing constellation. IC5017 lies among the faint stars of Lacerta the Lizard. You know what? I could see why that would look like a lizard. Can you guys? Look, this is the lizard. So it's above this house of Cepheus. And here's that big Andromeda thing. Big, the body of the Andromeda deal. So look how in between the house of Cepheus and the Andromeda deal, there you'd see the lizard. Look how it lies right in the middle of the Milky Way. Just playing with this to see what we can see on this one. This is a fiery hot planetary, isn't it? Another website says it's an Aquarius. Stu, thanks for having this book. Anyway, he tells you how to find it. It shines at just 12th magnitude. And he says it'll be hard to find. I wonder if we're looking at the right thing here. Oh, maybe it's this. Let's use our deep sky image annotation to be sure. Oh, way up there. Wow, it really is green, isn't it? Super green. Well, that's a tip-off, isn't it? Because very few stars are made of oxygen. But these planetary shells that burst out, yep, that's exactly it, Stu. Wilhelmina Fleming, 1904. Good job finding it online. (1,139% of our camera's optical ability. Let's turn off the deep sky image annotation now that we know which one it is. And just take in how small it is in this field. Still seeing it? So there's the full optical field. Do you still remember where it was? I think it's this one, isn't it? So So just check out how impossible that would be to discover this until you had the benefit of spectroscopes to tell that that's oxygen, or until you used electronically assisted astronomy and could see color like we can see it. Because prior to EAA, these would just be gray. As he notes in his book, he says it's just going to look gray. But then he says, when you get 12 inches and larger telescopes, it will take on a bluish tint. And then if you use an oxygen filter, he says there's a little hope of seeing the central star. Well, that's sad. I bet we could eventually see it if we stayed long enough. Oh no, it remains unseen even through the largest amateur telescopes because of the nebula's brightness. You can tell that, once again, it is lobed. Look how there's a polar nature this direction and a polar nature this direction. And look at the fade again at exactly the same points. So in other words, 12 and 6 are brighter, 3 and 9 are brighter, but 1:30, 4:30, 7:30, and 10:30, they fade. So it's IC5217. IC5217. No, they don't even have any astrophoto of it. IC5217. Oh my goodness. Cosmic Challenge is the top hit. Boy, not many astrophotos of it. None. My goodness, we should take an astrophoto. Okay, so I'm going to go print screen. I'm just going to go like this. It's pretty worthless. Pretty worthless, but we're going to save it. And that should be in desktop, sharp cap captures, IC5217. 9 minutes, 2023, 0930. How exciting. We just captured this astrophoto of this planetary nebula that we didn't even see on the web. The Little Saturn Nebula. Photo on that page at the bottom, Stu says, rats! I thought we were the first, Stu. Let's go back. Was it the, you're saying on the wiki page? There wasn't a wiki page, was there? Oh, I changed this wiki. I'm not seeing it, Stu. Tiffany's loving the green. Sky Live. That's kind of like our picture. We could take that. Boy, the Sky Live let us down. Where are you seeing that picture, Stu? go to this, images. No, Stu, is this it? Yeah, that's it. Oh my goodness. Look at that. Now that's just the hydrogen. So that's not showing the green. Okay, the Cosmic Challenge page. Let's go back to that. Maybe this, the little Saturn nebula. So you're saying in cloudy nights? Oh, well, it's a wild goose chase, isn't it? Ah, this is what you meant. Wow. "20" So you can see the oblong nature of it. When those layers are jettisoned, they are jettisoned and take on the polarity of the original object's poles. You know, like the sun has a north pole, and because the gases are ionized, they have polarity. So this might be the north pole, for example, of this inner star that we can't see. But we see evidence of the polarity of the inner star. It's pretty cool. Thank you, Stu, for finding that. Oh, by the way, while we're here, I just want to mention briefly that we've changed lists that we use for the email notification because some people were not getting the notifications. So we went to something called sender.net instead of the old-fashioned Google group. So now if you go to emeraldhillskies.com and just scroll to the bottom of any page, in the footer, there's now a form you can fill out, just 2 fields, and hit submit, and you'll be on the notification list. So that's what we used this afternoon. We used the Google group, and then later we did the sender.net. I'm hoping that people will be able to receive these notifications better than the notifications we were not getting from Google Group. All right, on with the show. We didn't do an observation of this, so we better log this real quick. 5217. Just going to say that we could barely see a polarity. Snapped a picture. Now I always forget, we can go here and say images, and we can upload, can't we? Can we? Ah, here it is. I knew there was a button here somewhere. So if we go to desktop and then, whoop, I went one too far. Desktop SharpCap captures, and then we go to IC5217. We can put that image, ever so ugly that it might be, we can put it in the observation. And I forget to do that, and it is an extra step, but at least we could be putting it there. And anyway, we could see, snap a picture of the polarity was hinted by the 2:30, 4:30, 7:30, 10:30 clock directions being dimmer. Save or cancel changes to the image path. I guess you hit that? Yeah. Now I wonder, once we have that, oh well, it's gone. Let's head to Stephan's Quintet, object 144, and the center of it is NGC 7318, I guess. Although there are several objects there, but we'll just use NGC 7318A as the kind of the central point of it. Wow, Stu just signed up. And he says now he doesn't have to rely on YouTube notifications. Well, that's awesome, Stu. Thanks for making that worth it. It took me a while to scout out the best approach so that we could have a reliable notification system. And it obviously wasn't reliable before using the old-fashioned Google group. They do say that if you're using Gmail, that might help to whitelist it or something, whatever. I don't use Gmail much, but I know there's something called a social tab and a promotion tab, and apparently it's pretty private only to Google what gets thrown into which tab. And so we'll see how this one does. I'm hoping it'll do better than the Google group did at getting it up in your heads-up radar list. So this Stephan's Quintet is actually a collection of NGC objects. Let's look at it in the planetarium software. So, yeah, there it is. So again, as far as context of the sky, this is Pegasus, the great horse, I guess. It's a little bit south of due east. And look at the number of objects in this part of the sky. Wow, a lot. We should be able to see this Deerlick group in the same frame. That'll be interesting. So this Stephan's Quintet deal should show us 4 main objects, and then this middle one must have multiple things going on. It's very interesting the way that they've interacted. Look at the way this arm has experienced a gravitational tidal effect, TID, like delta, TIDAL, tidal effect, when one of these other galaxies has sort of driven by it. And that drive-by effect has pulled that arm out of socket. Looks like there's a cluster overriding this, doesn't it? All right, let's go take a look and see what we've got. So there's in the middle there. Let's do this display histogram and get rid of some of that moonlight. Boy, we got rid of a lot of it, didn't we? When I'm making really fine tuning adjustments to these bars, these vertical bars in this histogram, I'm holding down that shift key because it gives you the ability to, it's a special kind of a fine tuning mode. Boy, they're not very pretty on a moonlit night. I'll give you that. Where is the moon here? Let's look at our sky cam. Okay, it's like everywhere. It's everywhere, the moon is. And that's a shame. So, in this view, where's the moon? Oh, right here. So you can kind of get an idea of how close you are to the moon with this angle measurement deal. Have I shown you that before? You drag like this and it tells you that the angle is, where is it? Oh, 45. Can you see up here to the right? See that little, see this little readout right here? Right now it says 6, 8, so we are 50 degrees away from the moon, and yet it's still obliterating our view on a 99% moonlight night. It's just making all of the background kind of a bright green yellowish, and that happens to be the color of these galaxies. Of course, we're just 4 minutes in, but still. This one's a lot brighter here. Look at this. Let's this is NGC 7331, but we're looking at 7318, which doesn't even show up until we zoom in. So 7318 is here. 7319 is here. 7317 is not on our list of cosmic challenges. 7320 is. Now that's 7320, but look at 7320C. And then out of that frame we were just zoomed in is this Deerlick group, which is also in the Cosmic Challenge. So we'll want to look that up here in a second. Quite a rich field of galaxies, huh? Oh my goodness, Kevin, thanks for pitching in. Planetaries and interacting galaxies are my favorite objects. Kevin pitched in $10, which will all go toward helping people in the earthquake-stricken region of Morocco, Middle Atlas Mountains there, the Imasichen Berber people that have lost everything, lost their homes, and on these cold winter nights coming up, they won't have anything. So thank you so much, Kevin, for that. All right, so Stu says 7318 is a pair of colliding galaxies about 280 million light years from Earth. They appear in the constellation Pegasus and are members of Stephan's Quintet. Tiffany signed up as well and hit the like button. Well, aren't you? You're so nice. Tiffany's reminding us all, if you like this kind of content, if you don't mind hitting the thumbs up or the like button and subscribing at YouTube, but you can also now subscribe at Emerald Hill Skies using that new little form, and it'll give you an alert every time we're gonna broadcast, every time we're gonna live stream. Stephan's Quintet is a visual grouping of 5 galaxies, of which 4 form the first compact galaxy group ever discovered. The group, visible in the constellation Pegasus, was discovered by Edward Stephan in 1877 at the Marseille Observatory. Stephan's Quintet was selected as one of the 5 cosmic objects observed by James Webb Space Telescope as part of the release of its first official science images. Well, that's fun. The group is the most studied of all the compact galaxy groups, and there are some amazing images online. Tiffany says to you, Stu, you are amazing. Thank you for the info. Good job. Tiffany says, Kevin, when you gave that $9.99 super chat gift, if you're interested in how he did that, there's a super chat button right beside the place where you're watching this chat. Stu, had a simulation program on my Apple IIe when I was a kid called Colliding Galaxies. Well, that's cool. Apple IIe. So, Stephan's Quintet is 144. The canvas on which our picture of the universe is painted relies on the unwavering acceptance of Hubble's law. Hubble's law states that a relationship exists between the distance to a galaxy and the speed at which it is receding from us. Excuse me. The farther away a galaxy is, the greater the speed of its recession, and the farther its spectral lines are shifted toward the red end of the spectrum. For Hubble's law and the redshift principle to be valid, it must work not just for a few galaxies, but for all. And indeed, it does. Well, almost. In the observable universe, there are a few notorious exceptions to these rules. One of the best known paradoxes is found high in the autumn sky, less than half a degree south of the bright galaxy 7331 in Pegasus. Stephan's Quintet was discovered in 1877, as Stu said. When Stephan first spotted, he thought it was a single object, but now it's known to be 2 separate overlapping systems, 7317 and 7318. I'm sorry, 7318. All are crammed within a tight 20 arc-minute area. So there's this controversy because the red shifts aren't working correctly like we thought they would. So some people feel like 7320 is a chance foreground object, but it matches 7331. Boy, with this moonlight and the amount of bleed in the sky, we basically just see these as fuzzy patches, don't we? Let's get rid of that swirl of annotation. We can barely see at 220% of our optical zoom. There's a fuzzy patch there. Sorry, a fuzzy patch here. Just a little bit of nebulosity there, and I'm not sure we would have picked this nebulosity out up here at the top. Yeah, I don't think we would have picked that out yet. But we are just 11 minutes in. Let's go ahead and add this observation. So this is the observation about 7318. And we're going to say we could see some mist, fuzziness in this patchy area, but not clear arms yet at 11 minutes integration. 222% of our RASA's optical, of our RASA ASI optical resolution. So we're kind of cheating. So that's 7318. 7318B. I don't guess I've ever, I don't know if you guys have or not, seen Stephan's Quintet live like this. I don't think we've observed it yet here at Emerald Hill Skies. So they're saying that there are two overlapping galaxies. It's NGC 7318 galaxy pair. Two overlapping galaxies there. Let's go back to our stellarium view and see if stellarium shows us a better picture of these. Oh, sorry. Yeah, boy, it's no wonder. This is 7318A and 7318B. I see, so there are two cores there. So these must be the two cores. Is that right? No, these then. These are. So no, yeah, so now let's get rid of the annotation. So these are the two galaxy cores for 7318. Boy, between the moonlight and the fact that this is such a small patch, we would have never known that those were two galaxies, would we? As NGC 7318b collides with gas in the group, a shock wave bigger than the Milky Way spreads throughout the medium between the galaxies, heating some of the gas to temperatures of millions of degrees. where they emit X-rays detectable, the NASA Chandra X-ray Observatory picked them up. The angelic figures at the beginning of the 1946 holiday film It's a Wonderful Life are based on images of Stephan's Quintet. I remember that. It's like, what was the one angel? Clarence and some other angel are talking, and when they talk, the galaxies light up, representing them talking. Boy, I'll see that in a whole different light now, Stu. Thanks. So these are 7318 and 7318b. Did we finish that? Yeah. And then 7319. Boy, they're not very well labeled here. Basically, they call the whole thing Stephan's Quintet, and everything is centered on 7318. But when we go back to SharpCap and we do the digital annotation, we actually can see 19 listed separately. So actually, deep sky annotation in SharpCap is helping us more profoundly than the planetarium software is. We could also see the fuzz of NGC 7319, but I don't think we could make out the distorted arm that's been pulled away. I don't think we can see that, can we? It would be somewhere in line with 3 stars. No. Maybe here? I don't think we're seeing it live. What about this? What is this? Oh, that's this. Which is 7320. This galaxy was much easier to make out in the Quintet. So when I first looked at these, I thought, well, it's called a quintet, but I only see 4 objects. See, look, I was basically 1, 2, 3, 4, but it's because these 2 cores are 2 different objects. So the quintet is 1, 2, 3, 4, 5. Jeff, great to have you aboard. Long time no see. We're doing well. Good to see you again. You're like up in Montana, I think, if I remember right. Have you been observing, Jeff? You still at it? Good to have you aboard. All right, so that's the end of the quintet, but before we leave here, let's try to figure out what this other group is, 7331. And why are we not seeing it here? Where is this Deer Lick group? Deer Lick 254. The Dirichlet group, I see, we've got this separated into 7338 as a double star. Oh my goodness. Yes, Montana, Jeff says. All right, take a look at this. This is live. This is not planetarium software. What we've done here is we're just overlaying the labels on top of the live view. So the first is 7338, a single star. Where is that? That's right here, NGC 7338. It says double star in the deep sky image annotation. So which is it? 7338. It is a double star. So we have it mislabeled here. Something mislabeled it, in spite of the fact that our observing software says single star. NGC 7338 is a double. Incidentally, if you've checked the original New General Catalog, you'll find 5 other entries in the immediate vicinity. 7330 is one of them. None is a distant galaxy, however, rather each is a misinterpreted, close-set double star, a faint individual star, or perhaps a figment of a tired astronomer's imagination. Of these, 7325 is the brightest of the missing deer, although it is nothing more than a very faint double set, 4.5 arc minutes southwest of NGC 7331's core. Even its brighter component shining at 14 magnitudes beyond the grasp of many backyard telescopes. So that's 7331. So do you think that since they're labeled as NGC, that the person making the NGC catalog was that Herschel? No. Thought that they were galaxies, but as it turns out, they're not. They're close-set double stars. Well, is labeled as a double in some atlases. We're at 175%. So do we think this, let's turn these off for a second. Is this the star that someone thought was a galaxy? You can see how that by zooming in, maybe it looked a little fuzzy. Looked like a little nebulosity, so they labeled it as a deep sky object. Cool aurora. So what we're going to say here is that they actually aren't deep sky objects. but rather single or apparent doubles. So the reason why we call it the missing deer-lit group, we call it that because there aren't as many galaxies in this group as what we thought. Instead, they're mislabeled stars. Is that your guys' impression? Salt lick enticing the quartet of deer. Fleas or deer notwithstanding, the most prominent of the four is NGC 7335. Says the hardest is NGC 7336. And it's almost impossible, even through his 18-inch. All right, on this 99% moonlit night, let's see if we can find it. NGC 7336. Let's go look at this in Stellarium first. NGC 7336 is here to the left, so it's like big Andromeda looking galaxy, although it's not Andromeda. 7335, and then off to the left is 7336. Oh yeah, so here's the big Andromeda looking galaxy, 7330. Whatever, deer-lit group, maybe 7331. So this is 7331, and then 7335, and then this is the one that he said would be hard even in his 18-inch, but it's showing up even in the moonlight here. Let's turn on our deep sky image annotation now. I did a solve only, yeah. 7336. So again, EAA rules. He's got an 18-inch telescope, dark skies, and he can barely see it using averted vision. And using electronically assisted astronomy on a 99% impossibly bright night. Remember, this is what our sky looks like tonight with the moon. Remember, this is the telescope. Look how bright it is. But EAA rocks because we're able to see the galaxy here. Clearly, and that's 18th magnitude, he says. Oval blur, 7336, 16.8, so 17th magnitude, 17. 7336. $73.36. Although we had to rack the ASI2600MC Pro to 326% digital zoom, making our objects very fuzzy and pixelated, we could clearly see 17th magnitude we could clearly see this 17th magnitude object as a fuzzy patch of mist, even with 99% moonlight. This is why I think you shouldn't get all, sad about being a moonlit night. We can still do astronomy. Look at these 3 galaxies in a row here. Bam, bam, bam. Can still do clear astronomy even though that moon is like a searchlight. This is 35 and that's 31. We can even see 33 here. Right there. 75. Island universe. Now, which is 7325? That must be one of the double stars. Yeah, up here. 7325. $73.26. 73.33. Single star. So what happened is the this and this began to look like galaxies because there were so many galaxies in this area. And it tricked the astronomers into thinking they were seeing other galaxies. Even with professional grade observatory telescopes, they were tricked. The big one is 7331, right, Stu? Jeff saw Aurora from his backyard of Bortle 6. Didn't even have to leave the city. "18 arc seconds, but eyeballs." Inverted vision is astronomer code for smoking dope. Yeah, it's out of focus. We are also, though, out of our optical zoom, but we could go focus real quick. You're right. We'll focus after we finish this object. It's been enough of a temperature shift that they are beginning to look like donuts. You're right. Good eye, Jeff. We started out focus an hour and 35 minutes, or an hour and 40 minutes ago, but the temperatures dropped. 7333 is another single star. Does that finish off 7337? Is that here as well? 7337, yeah. 7337 is a galaxy. So that's more of a splotch right here. Boy, you can see that now to us it just looks like a hazy patch, but that is a galaxy. We were starting to be out of focus, but could make out the hazy nature of this quote star as a galaxy. I doubt I can focus this just by let's try it though. Let's try going 100. Well, let's start out 30 in. I don't think it's going to show up well since I'm in live stacking. So we'll just finish out any other ones here. 7340. 7340 is down here. Another patchy universe island in the sky. Well, now we'll know what people are saying when they say the Deer Lick group. That finishes off the Deer Lick group. All right, let's go focus real quick. So we're going to disconnect this and disconnect the camera. I just wonder if we were to go look at the focus tools in Sharp Cap. Let's go out maybe right here. Get away from those patches. And just for fun, let's see what's the latest. This is a new version of SharpCap, just came out this week. Let's go to Focus Assistant. Yeah, see, there's nothing automated yet. Oh wait, automatic refocus. So let's connect the focuser. Automatic refocus. Uses the focus scan settings from your most recent successful focus scan or sequence autofocus. Use the focus scan system or sequence autofocus first, then try the automatic refocus tool again. So use the focus scan system. I've never used this before, so you're seeing this. This is live. What is focus scan? Contrast edge detection, histogram range brightness range detection, Fourier detail detection, multi-star full width half maximum measurement, full width half. So let's try this. Oh wait, we're live stacking. Let me get rid of this live stack. Okay. Now let's try setting this on 3 seconds at 400 gain. Okay. Now we'll go to Tools. Let's try multi-star full width maximum and see what it does. So those are all the focus stars. So is it automated? Is it doing it for us here? (7331, 7335, 7337 are known as the Deerlick Galaxy Group. Got it. Thanks, Stu. Boy, it does look sharper. Is it doing something? I can't even tell. Oh yeah, look, down here under now, it's going out to a bad area of focus. So let's look under history. Oh yeah, look. So these are getting worse. Look at the plus or minus. Is it doing this for us? I'm not very clear on how this works. Anybody know how this works? Anyway, now that looks pinpoint, doesn't it? Right? So can we stop this? Boy, I believe it helped. That'll be faster than going to Nina now. All right. You know what I'd be interested in doing since the moon is here with us? Let's do a couple of these moon features. You guys up for that? So what we'll do here is we'll look for the moon. I don't understand why sometimes it doesn't hear my, there we go, moon. And then we'll slew to it. And There we go. Just took a minute for everything to... Okay. Brace yourself. Everybody put on your shades. Stu says, yes, awesome. Been looking forward to the moon viewings. All right, everybody put on your Ray-Bans. Okay, we're going to take this down to like 0.3 and 100. How about 0.1? Okay, 0.2. Okay, would you believe 0.25? 0.275. 0.285. Okay. Now, I wonder if this will plate solve when you're aimed at the moon. I bet it won't. Not enough stars, in other words. No problem. I just wondered if SharpCap had any deep sky image annotation of the moon. I bet it doesn't anyway. All right, let's cancel out this. Let's just use Stellarium. Boy, that is so bright, isn't it? The first object they have us looking for is the Apollo landing sites. And this is number 46 in his Cosmic Challenge list. 46. So he's got these labeled in a nice little map here. And you see those little boxes with numbers in them? Look very closely. See, like in the Sea of Tranquility, Mare Tranquillitatis, see that 11? So that's where Apollo 11 landed. So let's get a big picture of this. And let's see if we can find the Sea of Tranquility, and in between the crater called Theophilus, and look how the Sea of Serenity is up there. In between the Sea of Serenity and Theophilus should be the Sea of Tranquility, Apollo 11. Got that? Easy, right? All right, so let's find the Sea of... Also find Theophilus crater first. Can we search for this? Like, does it let us search for things on the moon? Like yeah, it does. Theophilus crater. Oh, see, it put a little square there. I mean, crosshairs. Oh, yeah, there it's labeled now, Theophilus. So that's Theophilus. Right there is Theophilus. And I wonder if we can search for Apollo 11. Can we just search in Stellarium for Apollo 11? No such luck. Apollo? Oh, those are crater named after astronauts, I think. So that's Theophilus crater. Let's find the Sea of Serenity and the Sea of Tranquility. Are these going to be in Latin? Because I haven't had Latin since I was in 9th grade. Tiffany says, I never get tired of looking at the moon. Stu says, use Google Moon. Is there such a thing, Stu? All right. Now you've got my curiosity up. Google Moon. Oh my goodness. There is. Did you know this, Stu? Or were you just making that up? My goodness. Can we just go Apollo 11? No. Can we say Sea of Tranquility? Well, that's not very helpful. Sea of Serenity? What do we have to have? Like the street address or something? How does this work? Okay, Stu, I give up. I give up. Let's go back to Stellarium. I couldn't make it work, Stu. Let's remember that this is where Theophilus is. And now let's look for Tranquility. Mar Tranquillitatis. Boy, I can already tell. I'm going to have to study Latin again. Where is the crosshair now? I can't even find the crosshair. I'm not a very experienced moon observer, am I? Here's Tranquility. So remember that Theophilus was somewhere right here. This is Tranquility. That must be Serenity. So Apollo 11 must be right here by the Rimi Hypatia. Right there. Anybody see a flag? Okay, so let's memorize what this looks like. What is this crater? That is huge. Copernicus. So remember where Copernicus is, and what is this crater? Tycho. Okay, so we're basically gonna find Copernicus and Tycho and make a triangle, and the top point of the triangle will be Apollo 11. Okay, so let's go back to the live view now. Wow, that was easy, wasn't it? Let's brighten it up a little bit. That's let's go to 0.3 seconds. That's a little too bright. How did that get to be so bright all of a sudden? Okay, so this is Copernicus and this is Tycho, and right up here is Apollo 11, huh? That's Theophilus, right? So that's the Marnectaris, right? Stu says latitude 0.67 and 23.4. Are you serious, Stu? Boy, it just seems like it'd be better if there were deep sky image annotation on here for us. What crater is that, and that, and that? So this is it, right here. Remi Hypatium. See these two C's that are like circles right beside each other? They look like eyeballs, don't they? These two eyeballs. So here are these two eyeballs. And right here is where Apollo 11 landed. And I wonder if that's the lunar module right there. I'm joking. But it is interesting. That's right about where it would be. That's Theophilus, and this is Cyrillus. So the trick for us was the two eyeballs. And then there's a third eyeball here. So this is Serenity, Mars Serenitatis. This is Tranquility, Mar Tranquillitatis. And this is Fecunditatis. What is fecundity? And this is Nectaris, like nectar. So Serenity, Tranquility, Nectar, Fecundity. ChatGPT Stu is using to try to look up coordinates on the moon. Stu, you're just over the top. I've already learned more in 5 minutes than what I had ever learned before. Man, it's already 11:30. Rats. I had said we'd go 2 hours, and I know we're done with that. But we did find Apollo 11. So let's go here, add observation. And let's say we learned more in 5 minutes than I had in my entire previous life. Serenity, Serenitatis, Tranquility, and Nectar, no, Fecunditatis, whatever that is. Fecunditatis, Apollo 11, and then Apollo 17 landed right up here, pretty close then. Apollo 16 got out here, out of the sea, right here. Apollo 14 was right here. Apollo 12 was right here. And 15 looks like they were brave. They landed here on the bridge of the nose between the two eyes. So here's an eye, Serenity. Here's another eye, Tranquility. Here's the bridge of the nose. And this is where 15 landed. So that's it. 11, 12, 14, 15,